In this video, we are going to quickly look at a few of the different types of activities that you can find in the adding hundredths portion of my website. So I start with adding hundredths just because the place value is the same, and it really encourages students to use the strategies they're comfortable with when adding whole numbers to add decimal numbers. One of the biggest things to reinforce with students, especially those that are still practicing the skill of adding decimal numbers or fractions, is reading numbers correctly. So in the question that's on the screen, the students are trying to find the sum of 14 hundredths and 39 hundredths. Additionally, it's really important for me that students develop some flexibility and be able to recognize that regardless of whether the decimal number is written as a fraction or as a decimal, it still represents the same thing. They're still hundredths and they can still be worked with the same. Some students prefer to rewrite the fractions as decimals or decimals as fractions. It doesn't really matter. So in this case, what we're asking students to do is find the sum between 14 hundredths and 39 hundredths. So that'll require students to partition one of the numbers at least. So you'll see here in the bottom that this is the hundredths 02 deck. It goes all the way up to 7, and the partitioning required becomes a little bit more challenging with each step. So students can start with 2, and if they find it too easy, they can move up, or if they find it too hard, they can move back until they develop that flexibility. So in this case, the way that I'm going to think about it is 14 hundredths plus 30 hundredths plus 9 hundredths. So essentially all I've done is taken my 39 hundredths and partitioned it into some smaller parts. So now I'll look at 14 hundredths plus 30 hundredths, which gives me 44 hundredths. And all I have to add at this point is 9 hundredths. So the sum of 44 hundredths and 9 hundredths is 53 hundredths, or in French we would say 53 centièmes. And if students were working with the fractional representation, they might represent it like this. So what's important in grade 7 is to really understand that we're not timing students here. It's not a timed activity. However, we need to respect that there are strategies that are more efficient or more appropriate for grade 7 than others. So in this case, I've partitioned one of the numbers. You might partition both, but we really don't want to see students either counting on their fingers or making tally marks. If they're working with decimal numbers, if that's the case, then we need to practice whole numbers a little bit more. Move on to a different activity now. I call these dice sheets. So in my class, we use a die. But if you just go on google.ca and Google random number generator, you'll be able to put a minimum and a maximum and pick a number between 1 and 20. So for this activity, we need something that'll pick a number between 1 and 20. 2 numbers, in fact. So let's imagine that the first number that was generated at random by Google is 3, and the second number that was generated at random was 16. So the first number that we select will tell us which of the boxes to use in the first rectangle. So number 3 would be 1, 2, 3. So in number 2, I'll write 28 hundredths. The second number that was selected will tell us which box to use in the second rectangle. So 5, 10, 15, this will be 16 here. So in box number 1, I'm going to write 25 hundredths. Now what's important here is in the second rectangle to really recognize whether the number has to be written in box number 1 or in box number 3. Just to make sure that the equation is possible with positive decimal numbers and that we're not jumping ahead too many steps. So here we would just find the sum of 25 hundredths and 28 hundredths. which is 53 hundredths. If we move ahead, I just wanted to show an example of the hundredths 05 cards. At this point, students have practiced their partitioning skills, they've practiced they're comfortable working with hundredths, and now we're starting to see sums that cross over our benchmark of 1. So the sums will be larger than 1, and it also gives us a new strategy or a different strategy that we can use in order to find our answer. But in this case, we'll just look at 38 hundredths plus 65 hundredths. And I'll do the same thing here that I did for the first question. So 38 hundredths plus 60 hundredths plus 5 hundredths. So 38 hundredths plus 60 hundredths gives me a sum of 98 hundredths. And then if I add an additional 5 hundredths, I get 1 300ths. Or if you're working in fractional form, 103 hundredths. And it's really, really important that students be able to look at a fraction like this. So we call it an improper fraction because the numerator is larger than the denominator. But what's important at this point is that they recognize that this number is larger than 1. So if they're working with fractions and decimal numbers, they won't make a mistake in the place value and end up with an answer, for example, of something like that. So 103 thousandths. So I really like the fraction representation like this because I find it's easier for students to recognize whether or not their answer should be larger than 1 or smaller than 1, or if the numbers are bigger, larger than 2 or smaller than 2, etc. Thanks for watching.